So it is x-axis, y-axis and z-axis. Now if I'm moving in this direction like this, that means it is in one direction along x-axis, right? So this I can say it is motion in one direction, one dimension, right? If I'm moving along like this, okay, so this is also I am going upwards, that means motion in one dimension. I am moving along y-axis, okay. Suppose if I'm moving like this, that means I am moving in z direction, that means only in one direction, that means it is also motion in one dimension, right? So these are basically motion in one dimension. Now suppose if I say, like this, that means I am moving in x direction. See, I am my movement is in x direction and in y direction as well, right? So that's why I can say this is motion in two dimension. Okay, so this is basically motion in two dimension. So I can write it. Example of horizontal movement is like in an x direction, it's an horizontal movement. Suppose I am traveling in a lift, so can you tell me it is motion in one dimension or two dimension? It is in one dimension, because it is in y axis, because in lift I am going upwards like this, that means motion in only one dimension and in y direction, right? So these are basically motion in two dimensions. So I can write, if a body moves along two axes simultaneously, such a motion is known as motion in two dimensions. Motion in two dimensions. Now in this lecture I will explain an example of motion in two dimension. So this is very important topic, projectile motion. Very important topic of motion in two dimensions, right? So I can say it is an example of motion in two dimension. Okay, now I'll make a figure, because it is two dimensions, so I will just make two axes, x and y axis. So this is my x axis and this is my y axis. Now suppose there is a ball here and I'm kicking that ball with a certain angle, right? So I'm kicking that ball, so that ball obviously will go up, and then after attaining a certain height it will go down, right? So this is basically a projectile motion. And now you can see the ball is moving up, that means moving along the y-axis, and the ball is going forward, that means moving along the x-axis. So this is a perfect example of motion in two dimension, right? Suppose a ball we are kicking like this is making an angle theta here, right? And we all know if there is an angle theta, that means there will be a horizontal component and there will be a vertical component, right? Let us say the horizontal component is VOX and let us say the vertical component is VOY. Okay, now please understand, very important this concept is, there are, if a ball, I am kicking a ball and it is going in a horizontal and a vertical direction, that means on a ball there are basically two forces. The first force is along x-axis and the second force is along y-axis. So along x-axis we say it is a air friction force. right? And along y-axis, we say it is a gravitational force. Now, let us talk about air friction force first. So when we are kicking a ball, this is a ball, we are kicking, and then this ball stops somewhere here. Basically, the ball wants to go ahead, but there is a air force, there is a air friction force. The air is stopping the direction, the air is stopping the direction of the ball and stopping it for going ahead, right? You understand this? Air friction force. So suppose if I'm kicking ball like this, it comes here. Suppose now ball I am kicking, it comes here. Now the ball I am kicking, it comes here. So we cannot judge how far the ball will go, right? Due to this air friction force, we cannot judge because we don't know, we cannot measure the direction of the wind, the speed of the wind, okay, while doing the projectile motion. So in this case we neglect this air friction force because we need to do some derivations on projectile. So what we will do, we will neglect this air friction force because every time it is changing, right? So we are neglecting this, and we will consider only the gravitational force, right? Now, if there is a gravitational force, you all know the force due to gravity, right? So if I am just kicking a ball, so it is going upwards like here, but now due to the gravity here, it will come down. It cannot go up. It will come down definitely. Why? Due to this gravitational force, right? So after attaining a certain height, like here, after attaining certain height, the velocity will be zero here at topmost point, and then due to this gravity it will come down, right? So we will consider only the gravitational force, we are not considering the air friction force. Now if we are considering the gravitational force, right, that means force produces acceleration. If there is a force, definitely there will be a acceleration, right? And if there is a acceleration, you know what is acceleration? Dv by dt, that means rate of change of velocity, right? That means in vertical direction we will consider the rate of change of velocity, but now in horizontal direction we are neglecting this force, that means no force, right? That means zero acceleration, right? Because if there is a force, there is an acceleration and there will be change of velocity. If there is no force, obviously there will be no acceleration, zero acceleration. That means no change in velocity, no change in velocity. And if there is no change in velocity, that means we can say the velocity is constant. Velocity is constant. You understand? This is very important concept. In horizontal movement, velocity is constant. In vertical, velocity is changing, right? I'm just writing, this is very important concept you need to remember when I am talking about horizontal movement. Okay, we neglect the force, air friction force. There is no force, no acceleration, no change in velocity, right? That means what is there? Velocity is constant. Velocity is constant, right? So horizontal movement, velocity is constant. Now vertical movement. Vertical movement means there is a force, gravitational force. If there is a force, there is an acceleration. Acceleration means rate of change of velocity. If there is a change of velocity, then the velocity, we will consider this velocity in every case. So vertical, change of velocity. Horizontal, velocity is constant, right? Now come to this figure. So that means if a ball is here, if a ball is here, the ball will go here, the ball will go here, the ball will go at the topmost point, ball will go here, and ball will go here, and it will come down. So at every point where the ball is moving, the horizontal velocity will be constant. So there will be Vox, the horizontal velocity, Voy is the vertical velocity. Vox horizontal, Voy vertical velocity. At this point, Vox will be constant, but Voy will be 0 because this is the topmost point, okay, where it will attain a maximum height. At this point, Vox, but the direction of Voy will be downwards because the ball is coming downwards now, right? And here again Vox will be constant and Voy will be downwards. You understand this concept? So horizontal movement, velocity is constant, vertical, the velocity is changing. In the first half, the velocity direction will be the upwards. In the second half, it will be downwards. Okay, so I hope you understand this concept, and then we can obviously write the definition of a projectile. What will be the definition of a projectile? Such a motion in which a body is at a certain angle in such a way that it moves with constant horizontal velocity and at the same time it moves freely under the action of gravity, right? So this is basically the definition of the projectile motion. And remember the most important thing, this theta must be greater than 0 degree and less than 90 degree. Now suppose if it is 0 degree, that means the ball is not going anywhere, the ball is on the ground. That means it will be the motion in only one dimension, right? If it is 90 degree means the ball is going like this. That means the motion in only y-axis. So always theta must be greater than 0 and less than 90 degree if we are doing any projectile motion. This is the condition of theta for the projectile motion, right? Because if it is 0 degree, the movement is along x-axis. If it is 90 degree, the movement is along y-axis. Okay. Some examples of projectile motion. Examples is like a football kicked by a player. Second example, a missile shot from a gun. These are some of the examples of a projectile motion, or we can say an object thrown from a certain height. Okay, these are some of the examples of the projectile motion. Now, so like a projectile motion, just one more thing I need to explain. This is a projectile motion. So there is a term trajectory. Okay, and there is a term parabola. So there are so many shapes. Like triangle, square, hexagon. So we all know this shape. So the shape of this is parabola, and the path followed by the projectile is called the trajectory. So we can write this: path followed by the projectile is trajectory, and this trajectory is parabolic in shape. Okay, so these all things are clear to you. So projectile motion, the shape of the projectile motion is parabolic, and the path followed by the projectile is its trajectory, right? Now we need to do some derivations, but before moving to the derivations there are certain things you must know. So if it is an initial velocity, there are some terms we need to remember. If it is an initial velocity, then I will denote it with v naught, right? And if it is an initial velocity, I explained you vox and voy. So what is vox? It is initial horizontal velocity. And what is voy? It is initial vertical velocity, right? So initial horizontal velocity is v naught cos theta, and initial vertical velocity is v naught sine theta, right? Because we all know the horizontal component is cos theta, vertical component is sine theta. And if we talk about the final velocity, then we will say final velocity is v. So final velocity is v, initial velocity is v naught, right? Now what we will do, we will use these notations, and we will write some equations for the horizontal motion and for the vertical motion. This is horizontal and this is vertical, right? So we say, if we say horizontal, we say vertical. So the first expression we will write for the horizontal displacement. Horizontal displacement, right? For horizontal displacement, we all know the formula for the horizontal displacement is P is equal to V into T, right? We all know this formula. So what is that? S, because we are doing the x direction along the x-axis. So we say it is x. What we will say? V we will say Vox, and for T we will write T. So if we are speaking about the horizontal displacement, we will write this equation. Okay. Same for vertical displacement. If we speak about vertical displacement, we all know the equation of the motion. V equals to ut plus half gt square. Now what is V? V will be y-axis. U is the initial velocity, and what is the initial velocity here? V naught. So I will write here V naught, but because it is a vertical displacement, so I will write V naught y, right? T for time. Now I will write minus half gt square. I can say the equation is basically here. I must erase it. The equation is here A, right? And in this case, A equals to minus T, because the movement is with the gravity, and gravity is coming, due to gravity the ball is coming downwards direction. So we will say it is minus G, right? So we place this equation, and when we speak about the vertical displacement, we will write this equation, right? So always remember, during projectile motion, A equals to minus G. Now the second equation we will write for the horizontal velocity, right? For horizontal velocity, I explained you it is always constant. Why it is always constant? Because we neglect the air friction force. That means final velocity equals to the initial velocity, right? Now for vertical movement, we can say vertical velocity, right? So for vertical velocity, the equation, we will again use the equation of motion. V equals to U plus AT. And what will be V? We can say Y, or we can say Vy, right? What will be the initial U? Initial velocity will be Voy. A equals to minus G. So we can write minus GT, right? So we will use this equation for the vertical velocity. And the third equation for the horizontal acceleration. So what will be the horizontal acceleration? Because x-axis we neglect the force, there is no force, there will be no acceleration. If there is no acceleration, then I can say ax equals to 0, right? And in vertical direction, what will be my vertical acceleration? So vertical acceleration will be ay equals to minus g, right? So this will be my vertical acceleration because the motion is downwards. That means due to gravity it is coming downwards. So that means it is equal to minus g. So these are the three equations we will use for in the derivations, right? So these are basically the horizontal displacement and the vertical displacement. So now there is a heading, derivations of projectile. Okay, so again I'm just making again that x and y axis. So this is my x axis, this is my y axis, and this is the movement of parabolic. So this shape is parabolic shape, movement of the projectile, and the path it follows is trajectory, right? And this angle is theta, and this is a ball here, right? We are kicking the ball which is making a certain angle theta, going in a parabolic shape, okay? And this is an example of projectile. So now what are the derivations we need to do? The first derivation we will do is here, when the ball is reaching here at this point. So I can say this is total time to reach maximum height, right? Because this is the topmost point. So this is the total time to reach maximum height, which is equal to t, small t, right? Next derivation we will do here. This is a total time of a projectile. Total time of projectile when a ball is settled on the ground, right? So we will denote it with the capital T. The third derivation we will do of here, H max. H max is the maximum height attained by a ball, right? This will be this at this point, this will be the maximum height. And the fourth derivation we will do the range. Range is capital R. This is range, right? When a projectile, when a ball is stopped here, so where is the maximum it goes? That is basically the range, right? Range is basically the horizontal distance covered by a ball. So I can write is, what is range? The horizontal distance covered by a ball. So this is basically range, right? Now move to the first derivation. The first derivation is small t, and small t is time to reach maximum height, right? This is my first derivation. For this first derivation, we will use the first equation of motion for this maximum height, right? What we will use? This one, this equation, vertical velocity, Vy equals to V naught y minus gt, right? Because we are talking about the maximum height. So we will use this equation. So I can write Vy equals to V naught y minus gt. Now the vertical velocity at topmost point is 0. Okay, vertical velocity at topmost point is 0. So this velocity Vy will be 0, right? What will be V naught y? It's the vertical component. So we know this value. It is V naught sine theta. I explained you here. Yes, V naught y is equals to V naught sine theta. So we will come here, V naught sine theta minus gt. We need to find out the value of t. So we can write gt equals to v naught sine theta, and t will be equal to v naught sine theta over g. So this is a very simple derivation of t. T is the time to reach maximum height. So this is the time to reach the maximum height. V naught sine theta by g. Now the second derivation. Second derivation is capital T. That means total time of the projectile. So what will be my total time? See, you can see the figure here. So total time will be from here till here, it is t. From here till here will be t again. So what will be my total time? So total time will be t plus t. Or we can say it is 2t. Right? We can write this. So what will be my total time? So just use this expression and multiply with t. So we can write this sine theta by g. Simple. So this is my total time taken by a projectile. So these two derivations were very easy. So we will use these derivations, these expressions in the numerical. Now the third one, what we need to calculate? H max. H max is the maximum height, right? So what will be the maximum height? Height means we are talking about the vertical displacement of the projectile, right? Vertical displacement of projectile. So if I say vertical displacement of projectile, then I must go here and we must say this is vertical displacement of a projectile. This equation, y equals to v naught yt minus half gt square. So we will use this equation here. So I will just simply write this equation, y equals to v naught yt minus half gt square. So what is y now? It will be h max. Y equals to h max. V naught y, we all know what is that? V naught sine theta. And t, we have find out this small t. Small t, v naught sine theta by g. Now, this is the maximum height. We need to see what this t is. Is this small t or the capital T? So we will use the small t. Why we are using the small t? Because the maximum t is till here, the half motion till here. So we will use small t, right? So what is a small t? Small t is v naught sine theta by g. So we will use these things in this expression, putting the values, and we will find the expression. So the expression will be h max equals to v naught sine theta by g minus half gt square. So it is half gt square. That means this square. So it will be v naught sine theta by g square. Right? We need to solve this expression. So I can write h max equals to v naught sine theta square by g minus half g v naught sine theta by square over g square. From this g cancel, and we are taking this v naught sine theta square by g common, and what will remain here? 1 minus 1 by 2. That means what is 1 minus 1 by 2? Half. So I can write half v square sine square theta by g. Right? So I can say the final expression of h max equals to v naught square sine square theta by 2g. This is the final expression of our h max. Right? So this is the maximum height the ball will attain. Right? Now the last derivation is of range. Range, it is the, what is the range? Range, obviously it will be in x direction, right? And it is the horizontal displacement of projectile. range is the horizontal displacement of the projectile. So we will go back again here and we will see the horizontal displacement. So this is the formula, x equals to v naught x multiplied by t. So we will write this. So x equals to v naught x multiplied by t. Now again I will write what is x here. What is x? X equals to range, because it range we need to calculate. Vox component in the horizontal direction, that is v naught cos theta. Now the important thing is t. What we will take, the small t or the capital T? See, the small t is still here, but now we need to calculate the range. That means we need to calculate the total range. That means we will take the capital T here, total time taken by the projectile, right? So we will say it's T equals to capital T here. And what is capital T? Small t. What is the formula of capital T? We find out the capital T formula. Yes, 2 v naught sine theta by g. So it is 2 v naught sine theta by g. So 2 v naught sine theta by g. So what we will do, we will just put all these values in this equation. So x equals to r equals to v naught cos theta multiply by 2 v naught sine theta by g, right? So what will be my range? I can write v naught cos theta, we can write v naught square, just simplifying it, I can write v naught square 2 sine theta cos theta over g, right? And r equals to v naught square sine 2 theta by g, because in maths you have already studied sine 2 theta equals to 2 sine theta cos theta. So this is my expression of the final expression of range. Okay, now just one thing to remember, what will be my maximum range? That means what will be my R max? It is when theta equals to 45 degree. That is, it is the maximum range. So v naught square sine 2 45 degree by g, right? So we can say it is v naught square sine 90 degree by g, and that means what is sine 90? It is 1. So I can say R max equals to v naught square by g. So that is the formula for the maximum range, right? So by this, in today's class, we have learned 4 derivations of the projectile motion: small t, time, capital T, H max and R. So these are very important from exam point of view. Thank you so much.